Alright, pens down. Who got y equals sine theta? Well done if you did. If you didn't, don't stress. That is what y equals. We get sine theta equals opposite over hypotenuse. We know our hypotenuse is 1, correct? So we rearrange to get y by itself times both sides by 1. Y equals sine theta. So now I can replace y with sine theta. What can I replace x with? Cos theta. Now the beauty of this is that I can replace, if I get rid of all this triangle stuff, right? So if I get rid of all the triangle stuff in here, is that still true? Is the information still true?
Yeah.
Now regardless of what value you picked, that's still true, because I asked everyone in the room to draw a different spot on the line. So some of you will have it down here, some of you will have it up there, correct? So that's still true. You clear with that? This is where the value of trig comes in. I want you to pick the exact same point in this quadrant here. So find the same point in that quadrant there, within a reasonable amount. Within a reasonable amount, find the same point in the second quadrant that we got there. Now what I want you to do, guess what? Draw the triangle. Just looking at this triangle, tell me what you think is going to be the same. What's going to be exactly the same between the two? Angle's going to be the same, correct? Very good. What else? The hypotenuse is going to be the same, correct? It's still going to be 1. It's still 1 here, it's 1 the whole way around. It's always 1. What else is the same? Now remember I asked you to draw the triangle, the exact same. So what should be the same? Y will be the same, correct? X will be the same, but it will be negative, correct? Won't be negative cos theta, it'll still be cos theta. I want you to check this in a second though, okay? But you are correct, it will be whatever our X value was, but it will be negative. Now what I want you to do, just you're going to need your calculators for this part here, approximate your angle. Just trust me, it'll be easy though if you're pretty generous with the rounding. I don't care what your angle is, just has to be between 0 and 90. So like if I'm guessing about my angle here, so my original angle, I'm going to say it's about 60 degrees, right? So I'm going to guess that's 60 degrees. I want you to tell me what your cos and your sine values are. So find out what your x and your y values are. Now that you know this angle is 60. So above your little bracket where you've got sine theta and cos theta, write in what the values are if it's 60 or 30, whatever it happens to be. But you calculate it wrong, you've got it. Well, Ryan, the information you put is actually already on the board. Just use the 60 example. Now, what I want you to do, if that angle's 60, in my example, correct, what do I need to type into my calculator to find out these? Do I type in 60 or not? I need to type in this angle here, correct? That whole angle. So how do I find that angle? 180 take whatever my angle is. So if my angle is 60, it'd be 180 take 60. Now before you put it in your calculator, check what we did before, I want you to predict what the angles are going to be, what the answers are going to be. So put a prediction above and see if it matches up to your angle. Does that make sense? Now think back to what we know about this triangle. What do we know about this triangle? I predicted because I knew my y value should be the same, correct? So I'm going to expect it to be root 3 on 2, and I'm going to expect my cos value to be the same as negative, so it should be negative 1 on 2. Now to check that, I pull my calculator out, and I said, well, cos of 120 is, and sine of 120 is. Does that make sense? Do I need my calculator now? If I was to say, well, let's imagine, tell me what you think, if that's 60 there, I don't even need my calculator. You can tell me what sine 240 is. So you can predict those points. Tell me what those points will be. You're not allowed to pick up your calculator anymore. You have to tell me what these points are. Whatever value you've got, tell me what those points are. I'm going to get you to write down my points, and the second one gets you to tell me what's right on the board. So, you don't have to do your own, you can just do mine. So can you tell me, Amber, what should I write here for my x value? You don't know, have a guess. My x value was half here, it was negative a half here. What can you say about the x value at this point here? Negative a half, very good. Now my y value was root 3 on 2. What do you expect is going to happen down here? Negative root 3 on 2, correct? So what's the pattern? Whatever it was here, it's just negative for both, correct? Tom, the last one, can you help me out with the last one?
Half.
Yep. And?
Negative root 3 on 2.
Negative root 3 on 2. Well done. That's the unit circle in a nutshell. What do you notice about it? Is there a bit of repetition?
Yeah.
Fair bit of repetition going on. That's why trigonometry is valuable. So trig is all about things that repeat. Because once it gets past here, what's going to happen? It's going to be the exact same thing again. So think about some things that repeat. What repeats? What happens every day? The sun comes up, correct? Wake up, you go to school. Anything that's cyclical, anything that happens over and over and over again, can be represented with a trig function. Now there's a lot going on in that diagram. So I'm going to simplify it a bit for us. I'm going to give us a shortcut, but shortcuts for those who know the way, and I think now we know the way. So you're going to draw another unit circle here. A little bit less accurate this one. I don't care about the accuracy of this one.